In this video, we are going to look at a bunch of examples related to domain and range. So in this first one, we want to find the domain and range of the set. So the biggest thing that we have to remember when we're working with a set is that your domain, which we denote with a D, is going to be the set of X values, whereas your range, or the R, is going to be the set of Y values. So when we're given a set like this, my domain is going to be the set where all I do is list my X values. So here this is 3, 5, and 7. And my range is going to be listing my Y values, which you can notice in this case is just a 1. You only have to list it the once. Okay? Now that's all that this problem wants you to do. It just wants the domain and range. Now this next one wants you to find the domain and range based on the interval. So the way you do that is you want to look at your starting point on the most left-hand side. So that would be this point right here. This point falls at the point -2, -1. And then we want to go to the point that is the furthest on the right. And this point here is the point 1, 1. So your domain and range are going to be based on the X and Y values of your furthermost points. Now the other thing to keep in mind is that all three of these points are filled in, which means all of them are included. That being said, included means we use brackets. So one thing to keep in mind is that if you have a filled in point, then your interval is going to consist of brackets. But if you have an open point, then your interval consists of parentheses. Here these are filled in points, so we can start. My domain here is going to start from the most left X value, so it's going to be a bracket. We're going to start at -2, and then we travel along the x-axis over here till we get to 1 and close it. My range is going to go from my smallest, most negative, so we're going to start here at -1. Again, we open a bracket. We're going to travel all the way up as high as it goes. So if you notice, this point right here is the point -1, 4. And so we're going to go as high as up to the 4 and close it. Okay? So again, your domain travels along your X's and your range travels along your Y's. Alright, in these examples we are looking at what's called the implied domain. So the implied domain essentially means that now we are going to use some of the rules of our domain that we have. So here, one of the biggest rules we have is that we have a quadratic here. And so some of those rules, or what those rules essentially state, is that you have the rational rules, which say X cannot be 0 in your denominator. You have the radical rules, which say X must be greater than or equal to 0. And then you have everything else. And all else says that you have all real numbers. Okay? So here we are dealing with a quadratic. Therefore, my domain in this case is going to be all real numbers. So there are a couple of ways that we can write that domain. Now specifically here we want interval notation. So your interval notation says that we're going to go from -infinity to +infinity. Since we're dealing with the infinite spectrum, notice I use parentheses. The reason for that is because your infinities are not finite. They're never ending, therefore we cannot say that they have a finite included ending point. Now, if I look at this next one, notice it is a radical. So it falls under the radical rule, which says the stuff underneath the radical has to be greater than or equal to 0. So my domain here says that 9 minus x must be greater than or equal to 0. So what I have to do is solve for x. So here, negative x is greater than or equal to negative 9. X is less than or equal to 9. Remember the rules of your inequalities. If you multiply or divide by a negative, you flip the sign. So this means my domain here has to be written as an interval where 9 is my biggest value. So we're going to start at negative infinity. We're going to travel up to 9 and close it with a bracket. The bracket is there because of the equals. Now this last one, notice I have a combination both of my rational rule and my radical. So what this means is I'm still working with the stuff under the radical. So my domain here still works with 3 minus x squared. But because it's now in the denominator, instead of it being less than or equal to, it's just simply has to be, instead of it being greater than or equal to, it's just greater than 0. The reason for that is because if we equal 0 on the bottom, we break the rational rule. So we have to make that change. Now just like before, we're going to solve. So this is negative x squared is greater than negative 3. So x squared is less than 3. So x is less than plus or minus the square root of 3. And what this actually means is that we have negative square root of 3 is less than x is less than square root of 3. So the way that we would write this domain is we would start a parenthesis. We're starting at the negative square root of 3. We're traveling to the positive square root of 3 and closing our parenthesis. Alright, we want to do the same thing here. We want to state the domain, but in this case we have a quadratic underneath. So essentially we're using the rational rule. So what this says is that my domain is such that x squared plus 2x minus 24 cannot be 0, and I have to solve for x. So here you can use whatever quadratic rule you're the most comfortable with. I'm going to go ahead and factor. So this becomes x minus 4 and x plus 6. So I need to solve. So I have that x minus 4 cannot be 0, and x plus 6 cannot be 0. So x cannot be 4, and x cannot be negative 6. Therefore, because of that, my domain is such that I'm going to start at the negative infinity. I'm going to travel up to my smallest, most negative value first, close it. Then I have to union it to the next. I'm going to start where I left off, travel to my next stopping point and close. Then I need to union, and I'm going to start where I left off, travel to my next point, which is positive infinity. So you're starting at the negative and you're ending at the positive, and you need to make sure that you include this middle piece right here. Okay? Alright, here I have y equals the square root of x. So if you think about the way that looks graphically, if you were to look at its graph really quick, because we're a square root, we're going to start here at 0, and we're going to come out in both the positive and negative direction. So what you want to notice here is that my domain is going to be all real numbers. However, my range is going to be slightly different. Here we're going to start at 0 and travel on forever. So we've got 0 to positive infinity. Now this other one, x equals 3, if we think about the way this graph looks, okay, so if I draw this graph, so I've got 1, 2, 3. So x equals 3 is essentially the line that drops straight through here and goes like this. Now, however, it is a vertical line and it is x equal. So when we're talking about your domain, in this case, it is undefined, which is going to hold true for your range. Alright, let's take a look at this next one here. So we have to state the domain and the range of the function. So just like with that first graph, we want to look at the start and stop points, and we also want to look at these middle points as well. So let's start with the uppermost part. So here, this coordinate is going to be at -7, 8. And this other coordinate down here is going to be at the point 5, -6. And notice my two inner points here are included. Okay, so that's important that this point right here and this point right here, these are included points, which means they would be brackets. Now the other thing that we need to keep in mind is that this point down here is included, but this point up here is not. Okay. Since these middle points are included, we can ignore them when writing our domain. So in this case, my domain is going to start from the leftmost point. So that's going to be that I start with a parenthesis at -7. I'm going to travel along my x-axis till I get to my furthest most right point, which is going to be here at 5 with a bracket. My range is the same idea. I'm going to start with the most negative y value, which is going to be here at -6. I'm going to travel up until I get to my highest y value. Sorry, it's not a parenthesis. This right here is a bracket. All the way up to 8, which is my parenthesis. Okay, domain and range. Alright, now the last thing that I want to look at right here is this question where we are given g of x plus a minus g of x. And we are provided the following information. We're given g of x. And so what we have to do is we need to determine what this piece here is going to be. Okay. So the first thing we need to do is we need to find, so this is the first thing, we need to find g of x plus a. So this says I'm going to have -4 times x plus a squared plus 3 times x plus a. So here this is going to be -4 times x squared plus 2xa plus a squared, and this is plus 3x plus 3a. The reduced is going to be 4x squared minus 8xa minus 4a squared plus my 3x plus my 3a. Now that we know x plus a, we can plug everything together. So I want g of x plus a minus g of x. So that's going to be what we just found here, -4x squared minus 8xa minus 4a squared plus a 3x plus a 3a. But then we have to subtract out my g of x. So I'm going to open a parenthesis here, and this is minus a 4x squared plus a 3x. The last thing we have to do is simply reduce. So I'm going to take this negative and distribute it through my parentheses here. So we're going to end up with negative 4x squared minus 8xa minus 4a squared plus a 3x plus a 3a plus 4x squared minus a 3x. If you notice, I have a 4x squared and a 4x squared, so those can cancel. And I have a 3x and a negative 3x. So all of those can go away, leaving behind just my a terms. So this is going to be negative 8xa minus 4a squared plus a 3a. Now the reason why a problem like this is important is because it's going to set you up for being able to do the difference quotient, which is what we will be getting into in my next lecture video. So if you have any questions about finding the domain or the range of your functions, please let me know. Otherwise, I do hope this video helped, and I hope you enjoyed yourself as much as I did. So I'll see you next time.